So my screen is visible, I think so. Yeah. So today we'll
Yes.
start about the last class we seen the gate level modeling. No, today we'll start about the operators. What are the operators we have? Okay, so we'll start the operators and we'll try to complete the operators and signed and unsigned numbers. Okay. Uh, is it fine? No, I'm audible and the screen is visible, so that I will move forward. Yes.
Yes.
Can you respond? Yeah.
Yes. You
Hope
are
you
audible.
audible. So today
Yeah.
we'll discuss about this first operators in Verilog. Okay, operators in Verilog. Operators in Verilog. So first we'll see this logical operator. So what is this logical operator? So logical operator. Okay, first we'll see logical operator. Logical operator. So logical operator. In this logical operator, you have logical and, okay, and the symbol is double ampersand, and logical logical or logical or uh, so like two slashes like this, okay, and next you have logical not, okay. So logical not is this symbol, okay. So the value of logical operator, the value of logical operator lies, it can be either only these three values are there: 0, 1, and either it may be x. Okay, this is the value of logical operator. Okay, so uh, suppose, example, we take one example, logical and I am explaining logical and. Let us take reg 1 down to 0 a, okay, reg 1 down to 0 a, and reg 1 down to 0 b, 1 down to 0 b. I am giving x equal to a logical and of b, a logical and of b. Okay, so a logical and of b, let us take a equal to 2 tick binary 0 1, and b equal to 2 tick binary 1 0. Okay, so if it is a non-zero value, it will take total value as 1. Okay, if it is a non-zero value, it will take total value as 1. So that is 1 logical and of 1. So that means the result is what? X equal to, you are getting 1. X equal to 1. Okay. Suppose if you are taking a equal to 2 tick binary, let us take 0 0. Okay, b equal to 2 tick binary 1 0. Okay, so if it is a 0 value, it will take whole value as 0. If it is a non-zero value, it will take whole value as 1. Okay, so that means here you will get 0 logical and of 1. This is equal to, you are getting 0. Okay, so this is the logical and operation. Okay, so that
Sir,
means
first,
I can say that in
sir,
logical operator, so I can say that you need to remember that in logical operator, the entire value, whatever the entire value is there, entire value uh, is treated as 1. Entire value is treated as 1, or it is treated as 0. Treated as 0. Okay, this is logical operator. Let us take one more example. Suppose example 2. Example 2. Let us take, suppose, that means here, suppose a equal to 2 tick binary 0 1 means it will take the total value as 1 or true condition. Okay, b equal to, suppose 2 tick binary 1 0 is there, so 1 0 means it will take the total value is 1 or true condition. Okay, if a equal to 2 tick binary 0 0, it will take the total value as what? 0. If all values are 0 means what? It will take total value as 0, that is false condition. Okay, so suppose like let us take a equal to 2 tick binary, it may be any bits only. Okay, total value if it is a non-zero value, so normally suppose if you take this value in decimal, this is 1 and this is 2 and this is 0, no. So here also suppose this is 3, this is a non-zero value, it will take total value as what? 1. Okay, so b equal to 2 tick binary, let us take 0 0. Okay, this is in decimal 0, so this will take total value as what? 0. Okay, so if you consider x equal to a logical and of b means x equal to 1 logical and of 0, you are getting the result as 0. You are getting the result as 0. Okay, so like this you need to analyze. Okay, suppose let us take example 3. Suppose a equal to 2 tick binary 1x, 2 tick binary 1x. Okay, so this is so total value it will take as x. Okay, as I told you, the value for the operators will be either 0, that is false condition, 1 true condition, or it may be x. Okay, don't care. So B you take as a 2 tick binary 0 0. 0 0 means this will take total value as 0. So x equal to what? A logical and of B means so if you see this one, so this may be either 1 and or 0, no. So 1 logical and of 0 means you are getting 0, 0 logical and of 0, you are getting 0 only. So that means here you are getting x equal to what? 0. X equal to 0. Okay, so like this you need to see the logical and operation. Okay, so if you see logical or operation, if you see the logical operation, same case, if you see suppose y equal to a logical or of b. Okay, so when I am seeing this, so that means 1 logical or of 0, you are getting 1, and 0 logical or of 0, you are getting 0. So that means one time you are getting 1, other time you are getting 0, so that means the result will be what? X. The result will be x. Like this you need to get. Okay, hope you understand this logical operator. And suppose so we'll take example, next example. So suppose a equal to 2 tick binary 1 1, this will take as what? 1. Okay, b equal to what? 2 tick binary 0 1. Okay, this will take total value as 1 only. Okay, so y equal to a logical r of b. Okay, this is logical r, this is the symbol for logical r. Okay, logical r. So 1 logical r of b. Okay, y equal to 1 logical r of b means 1 logical r of 1. So that means here you are getting y equal to what? 1. So 1 or 1 equal to what? 1 only you are getting. Okay, and similarly, yeah, you can take like this. Okay, so same thing like reg 1 down to 0, you take a 2 bits, reg 1 down to 0, b 2 bits, and so that is result equal to what? Result equal to a logical r of b. Okay, so a you take as 2 tick binary 1 1, and b you take as 2 tick binary 1 0. Okay, this it will be 1 true condition, this will be 1. Okay, so what is the result? Result will be result will be what? Result will be uh, so as this if you take result also. Okay, let us take result also, reg 1 down to 0, result is also 2 bit. Okay, now you will get what? Result equal to 0 1 you will get. Result equal to 0 1 you will get. Okay, and next is logical not. Logical not means suppose a equal to, let us take 3 tick binary 0 1 0. Okay, this will take as what? 1. Okay, and reg y, I'm initializing reg y, and y equal to what? Not of a. Not of a means what? So y equal to not of 0 means y equal to what you will getting? 1 you are getting. Okay. So this is about logical operator. Uh, yeah, hope you understand this logical operator. So I will open this code, Vivado, and yeah, I will open this code and I will show you how to execute this logical operator. One second. Yeah, Verilog programs. Yeah, logical and bitwise operators. I am opening the Vivado. It will take some time. Okay, this one I am closing. See here, this is a logical operator I wrote. Here logical AND operation. Okay. So this is logical AND operation. Okay. So logical AND operation, if you see here, so here I initialized this logical AND. So I initialized the reg 2 down to 0 A B C and reg XYZ initial begin and A equal to what 5. 5 means this is 3 bit. It will take as what 101. Okay. And B equal to 111. Okay. And C equal to that is tick binary X. Okay. Tick binary X. So I am calculating X equal to A logical AND of B, Y equal to A logical AND of C and Z equal to B logical AND of 0. Okay. So this one, so what you will get the output, so here if you see, I took the output, I took this, yeah. So what I took here, A equal to 5, okay. B equal to what, so B equal to, so B, so if you see B equal to, so B equal to 3 ones and C equal to X, okay. So B equal to 111 and C equal to XXX. This is a 3 bit and this is nothing but 101. Okay. First what I am doing, first what I am calculating. So here X equal to A and B, Y equal to A and C, Z equal to B and 0. Okay. So X equal to A and logical AND of B, Y equal to uh, um, Y equal to B logical AND of C, no? So Y equal to A logical AND of C and Z equal to B logical AND of 0. Okay. So so B logical AND of C and z equal to a logical and of 0, okay, or a logical and of c, or b logical and of, so anything you can do, okay, in this program. uh, so a logical and of c and b logical and of 0, okay. So here if you be logical and of 0, okay, so that means it will take as what, 1, it will take as 1, and it will take as x, okay. So now x equal to what, x equal to 1 logical and of 1, okay. So x equal to what output you are getting, 1 only, okay. And next y equal to a logical and of c, so a logical and of means 1 logical and of x. So that means one logical and of, don't care values are either 0 or 1. No? So logical and of 0 means here you are getting 0. Logical and of 1 you are getting 1. Okay. So that means here you are getting y equal to what, x. You are getting two values. So that means y equal to x. And z equal to what? Z equal to b logical and of 0. So what is b? B equal to 1 logical and of 0. So this is equal to z equal to what? 0 you'll get. Okay. So here what I am doing, just I am displaying this. Okay. Dollar display, the value of x is percentage b, value of y is percentage b, z is percentage b, x comma y comma z, the result, wherever the result is there, I am storing, okay. So here I wrote these programs. So here go to the simulation, whatever the program you are simulating, you need to make as top module, okay. So which module I am making, this is this one, no, logical and, okay. So logical and making, you need to right click, set as top module. Need to right click, set as top module, run simulation, run behavioral simulation, run simulation, run behavioral simulation. So if you see in the TCL console, you got the output. The value of x is 1, the value of y is x. The value of x is 1, the value of y is x, the value of z is 0. Okay. So like this you can analyze the logical operator. Okay, logical and operator. So just to come out from the simulation, and if you want to, one second, I closed, sorry. Yeah, I'm opening again. Suppose same thing, same value, if you want to do for same values I'm giving, I want to, so what values I gave, a equal to 5, b equal to triple one, and c equal to xxx, no. So I want to use logical r, okay. So what are the outputs you can analyze, see here. So a I took, this is three variable. So a I took as what, a I took as mm, uh, 5. A I took as 5. Okay. One second. I'll close this magnifier. Yeah. And B I took as what? B I took as triple one, and C I took as XXXX. Okay. So here I need to do which operation? Previously I done logical and, no. So I am first, now I am doing x equal to a logical or of b, and y equal to a logical or of c. Okay, z equal to what? Z equal to b logical or of 0, no. So b logical or of 0. Okay. So this is 101. If it is a non-zero value, it will take as true condition. This is 1, and this is 1 only, and this will take as x. Okay, in logical operator. So here if you see, so x equal to what? 1 logical or of 1. So that means here x equal to, you are getting 1. Okay. And next y equal to 1 logical or of x, 1 logical or of x. So what are the values of x? X may be either 0 or 1. So 1 logical or of 0 means you are getting 0, 1 logical or of 1 means you are getting 1. Two values you are getting. So that means what is the value of y? It will take as x. sorry, you are getting 1 only. Both values you are getting 1, no? So previously you got x, here both values you are getting 1. So it will take as 1 only. And z equal to b logical or of 0. B logical or of 0 means 1 logical or of 0 means z you are getting as 1. Z you are getting as 1. Okay. That I will check in the Vivado. So this one, logical or operation. Okay. So same values I took. Okay. So that means, one second. Same thing, module logical or range 2 down to 0 ABC. So I'm using a vector and I'm initializing with 3 bits, and range XYZ. These are the results. Initial begin A equal to 5, 3 and B equal to 3 tick binary 1 1 1 and C equal to tick. I'm not initializing the size means by default it will initialize with 3 variables. Okay, X equal to A logical or of B, Y equal to A logical or of C, and Z equal to B logical or of 0. And next I am displaying this value. The value of x is percentage b, y is percentage b, and z is percentage b comma x comma y comma z, and end module. Okay. So just whatever the code you are executing, that you need to take as top module. So which one you are executing, logical or no? So right click and set a stop in the simulation sources. Okay. So here run the simulation, run behavioral simulation. Yeah, save this project. See this output. So you are getting x equal to 1, y equal to 1 and z equal to 1. This is nothing but logical R. Okay. And so just to close the simulation. And logical not means what? Logical not means you took a equal to 5, b equal to triple one, and c equal to x means this will take as a true condition 1. This will take as true condition. This will take as x. Okay. So not of 1 means you are getting 0. Not of 1 means you are getting 0. Not of x means what? Not of 0 means 1. Not of 1 means you are getting 0. So that means you are getting like x condition. Okay. So here logical not, right click set as stop module, and next run simulation, run behavioral simulation, run simulation and run behavioral simulation. So here you see what you are getting. The value of x is 0, y is 0 and z is 0. Okay. So this one you check the output in the EDA playground also. Okay. Suppose logical and I told you, no. So logical and I told you. Okay. Logical and, just to copy this code and open the EDA playground. Okay. Yeah. EDA playground. EDA playground. So this one. So you copy in the design source and go to tools, select Aldec Rivera, languages is system Verilog or Verilog, run this code. You are getting the output. The value of x is 1, y is 1 and z is 0. Okay, you can execute in Vivado as well as you can execute in this one. Okay, so this is about the logical operator. And next is bitwise operator. So what are these bitwise operators? We'll see. Okay, so bitwise operators. One second. Bitwise operators. Yeah, I'm sharing my screen. Yeah, bitwise operators. So if you see the bitwise operators, so bitwise operators, these bitwise operators uh, are like AND gates and OR gates and all that logic gates. So bitwise operators. Okay, magnifier I will close. So bitwise operators. You see the bitwise operators. One is AND operator, AND operator. This is AND operator. This is the symbol. And next is OR operator. Okay, OR operator, and XOR operator, XOR operator, and XNOR operator, XNOR operator. So not of XOR or not of XNOR. Okay, so these two symbols are there. And next negation, negation, or bitwise not. Bitwise not. This is the symbol for negation and bitwise operator. Okay. So what are these bitwise operators? Bitwise operators operator. The operation is performed on each and every bit. Okay. So bitwise operators are nothing but the operation is performed on each and every bit. Each and every bit. Okay. Suppose we'll take one example. Example one. So if you see, let us take reg 1 down to 0. Let us take a comma b, and reg 1 down to 0. Let us take c. Okay. Initial c equal to a and b. And c equal to a and b, and let us take a equal to 2 tick binary 1 0, and b equal to 2 tick binary 1 1. Okay, so when you do the bitwise AND operation, so each and every bit it will do the operation. This is 0 and this is 1. So what is the value of c at last? C equal to 2 tick binary 1 0 you will get. C equal to 2 tick binary 1 0 you will get. Okay, so this is example. And consider another example. Let us take example 2. So a equal to 2 tick binary 1 0, b equal to 2 tick binary 0 1, and reg 1 down to 0, a comma b, and reg c initial begin. Within the initial begin and block, I am writing c equal to a and b end. Okay, so that means this value it will take as 1, this value it will take as 1. Okay, so c equal to 1 sorry, this is logical operator, no, sorry. So bitwise means it will do the bitwise operation. So here it will do. So what it will do? So that is 1 0 and 0 1. So bitwise AND operation it will do. Okay. So you'll get 0 0. So that is c equal to what? 0 0 you'll get. Okay. C equal to 0 0 you'll get. Okay. So here so that means reg c. So I initialized what? I initialized this is reg c. Reg c is how many bit? 1 bit. So 1 bit. That's why here the result is in terms of 2 bits you will get. But I initialized reg c. Reg c is when you are representing reg value. This is 1 bit only. So this is 1 bit means at last you will get the result c equal to what? 0. At last you will get c equal to 0. So this is example 2. And next let us take example 3. A equal to 2 tick binary 1x, b equal to 2 tick binary 0 1. Okay, I'm using reg 1 down to 0, 1 down to 0 y, okay, 1 down to 0 y equal to a logical and of b, a logical and of b. So that means here 1x and logical and of 0x, okay, 1x 0 1, 1x 0 1. So 1 and 0 is 0 only, here you need to analyze. So the x value is what, either 0 or 1, no? So 0 and of 1 is a 0, 1 and of 1 means here you are getting 1, okay. So that means this is nothing but what, x, will get x, okay. So like this you need to analyze the bitwise operators, okay. So for the bitwise operators, if you see for the programming, I'll take the same value. Let us take a equal to 5 and b equal to 3 tick binary 111 and c equal to what, c equal to tick binary x, okay. So this is 101 only, so this is 101 and this is 111 and this is xxx, okay, this is xxx, okay. So here suppose if I am doing logical, so that means x equal to logical and of b, okay, sorry, bitwise and of a and of b, bitwise operation I am doing, and y equal to a bitwise and of c, and z equal to b bitwise and of 0, okay. So if you do this, what you will get, 101 and b means what, 111, what you are getting, this is 101, okay. This c, so that means x equal to you are getting 101, okay. And a and c means what, 101, a is 101 and c is xxx, okay. So when you do this, so 1 and of x means what, 1 and of 0 is 0, 1 and of 1 means 1, so here you are getting x. So 0 with 0 and with x means you are getting 0 only, here you will get x, okay. So that means here y equal to x 0 x you will get, okay. And z you take, z equal to what, z equal to so b is what, b is 111 uh, logical and of 000, okay. So you are getting 000 only, okay, you are getting 000 only, okay. So these are the values you will get. Same values if you check for logical or, logical or means okay, one second. One second. Hello, yeah. Next, one second.
డోర్ ఎందుకు ఓపెన్ చేస్తలే
డోర్ ఓపెన్ ఉందండి నేను ఇక్కడ.
ఫ్లాష్ అయిపోయిందా అందుకని రాలేదు
Next, if you see, this is logical or, logical or you can see that means 101 and logical or of b, so 111, both are 111, logical or means all ones you will get, okay. And next a and c, so 101 and xxx, okay. So 1 with x means you are getting 1 only, okay. Here you will get x, 1x1 you will get, okay. And b and c means what, b means 111 and 0, all ones you will get, okay. So this is about the bitwise operators. Just I will show you in the Vivado tool how to execute this. Yeah. uh, so you need to like so logical and operation, logical and XOR XNOR, like that also. So logical and, so logical sorry, bitwise and, This is the code for bitwise AND. Okay. So whatever the code you are executing, right click, set as stop, right click, set as stop. Okay. And run simulation, run behavior simulation. So here you will get the value of x is 101, y is x0x, and z is 000. Okay, like this you will get logical and close the simulation and bitwise R will see bitwise R. This is bitwise R. Okay, bitwise R. So in the simulation sources, set as stop module. Need to set as stop module and run simulation, run behavioral simulation. So you'll get the value, that is the value of x is 111, y is 1x1, z is 111. Okay, and close the simulation. We want to see the bitwise XOR also. Okay, this is bitwise XOR. Okay, that you can analyze. Okay, set as stop. It will do the XOR operation. Bitwise, it will do the XOR operation for each and every bit. Okay, run simulation, run behavioral simulation. So here you are getting the output as what, y, the value of x is 010, y is xxx, and z is 111. Okay, that is XOR operation. And similarly, you can see for XNOR also, bitwise XNOR. Okay, this is the symbol for XNOR operation, bitwise XNOR operation. I am taking the ABC values so same only, and I am checking for different bitwise operations. Okay, so right click, set as stop module, set as stop module, run simulation, run behavioral simulation. So these are the outputs you are getting. X equal to 101, y equal to xxx, z equal to 000. So that you can analyze. And next, bitwise not, bitwise not. Okay, so bitwise not, right click, set as stop module, set as stop module, run simulation, run behavioral simulation. So here you will get the value of x is 101, no? So each and every bit will be complemented. 010 you'll get. Okay, and y is what, 111, no? So each and every bit will be complemented. That becomes 000. And z is what, xxx. So x complement of x means what you are getting? You are getting x only. So that is you are getting x only. Okay, like this you can see the outputs. Okay, so this is about the logical operators and bitwise operators. Hope you understand. And next is reduction operator. Okay, next is you have reduction operator. Reduction operator. So reduction operator, so you have so this we call as, mainly in the operators there are three types are there: unary operator, binary operator, and ternary operator. So unary operator means you have only one operator. Okay, this reduction operator is unary operator. Okay, unary operator. And binary operator means you have two operands. Okay, so this logical and bitwise, relational, uh, equality operators, these are nothing but binary operators. Ternary operators means which are having three operands. Okay, like ternary operators means you have like one operator that we will discuss. Ternary operator. Suppose so this is reduction operator. Suppose if you consider AND operator. So reduction AND if you consider. So the symbol is x equal to what? X equal to AND of A. Okay. Suppose if you A equal to, let us take 101. Okay, so what it will do? It will do the AND 1 and 0 and 1. So total value is 0. So that means here, so x equal to what? X equal to, you are getting 0, like this. Okay, and reduction R also. Okay, this is reduction and next reduction R. Reduction or reduction or is x equal to r of a. This is the symbol. Okay. So a equal to, let us take 101, and so 1 r of 0 r of 1. Okay. This is you are getting 1. Okay. X equal to what? You are getting 1. You are getting 1. Okay. And reduction NAND. Reduction NAND. So reduction NAND means so the symbol is like x equal to not of and of a, not of and of a. Okay, this is reduction, reduction NAND. Okay, reduction operator. Okay, this is the reduction operator. So here first you know that a equal to what? 101. First it will do the AND operation, that is 1 and 0 and 1. Okay, this is the AND operation, that means AND of a. So that means AND of a, what you got? 0, no? So not of AND of a means what? You are getting 1. Okay, this is nothing but reduction NAND. And next is reduction NOR. Reduction NOR. So reduction NOR is so x equal to so nor so this is the symbol. Okay, so nor of a. Okay, so you know that a equal to what? 101, and so 1 r of 0 r of 1. So any one of the input is 1, the output is 1, no? So this is r of a. Okay, so this is nothing but r of a. Okay, again complement in it, you need to do the complement. So this you are getting 0. So this is reduction nor. And next reduction XR. 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 X equal to XR of A. Okay, let us take A equal to 101. So 101 means 1 XR 0 XR 1. So you are getting 0 only, no? So that is x equal to 0 you are getting. Okay, X nor, reduction X nor. Reduction X nor. Reduction X nor means x equal to not of XOR of A. Okay, so if you take A equal to 101, 1 XOR 0 XOR 1 means so this is XOR operation means you are getting 0. Not of XOR of A means what? You are getting 1. Okay, so here at last you are getting x equal to what? 1. Okay, so these are nothing but reduction operators. Okay, hope you understood the reduction operators. Any doubts or queries? If you respond so that I will move forward, but yeah,
No, you can move forward.
okay. Next, concatenation operator. Okay, what is this concatenation operator? Concatenation operator. So concatenation operator. Here, if you see the concatenation operator, uh, so let us take a equal to 101 and b equal to 011. Okay, concatenation is nothing but what? Combining. Concatenation is nothing but what? Combining. Okay, let us take that means suppose here x so x equal to, I am concatenating a comma b. So what is the result? X equal to 101 and 011, like this you will get. Suppose x equal to, I am concatenating b comma a. X equal to what you are getting? 011 and 101. Okay, just combine. Okay, and I can concatenate with 1 bit also. Suppose if you consider so you can write x equal to b of 0 comma a. Okay, so this is the index 0 1 2. So that means I'm concatenating the lsb bit of b. So what is the lsb bit of b? That is b of 0, that is 1 1, and with a 101. Okay, like this I can concatenate. Okay, and next is a repetition by using concatenation. Repetition by using concatenation. Repetition using concatenation. So what is this repetition by using concatenation? Suppose x equal to, let us take 2 of x. Okay, 2 of x. Let us take x equal to 101 and 101. Okay, so that means here, uh, uh, so let us take x or 2 of a if you consider. What is a value? 101. No? So I am repeating for 2 times. Okay, and so you can consider like x equal to a comma 3 tick binary 000. So if you do this, you are getting 101 and 000. Okay, so this is concatenation. Repetition. Concatenation is nothing but combining. Okay, combining. Okay, and next, next is shift operators. Okay, so what are these shift operators? Mm, shift operators. Shift operators. Shift operators. There are two types. Are there? One is logical shift, and next one is arithmetic shift. Logical shift and arithmetic shift. So what is this logical shift? We'll see. Logical shift means so the symbol for the symbol for logical shift is either. So again these are divided into three types, two types: left shift, logical left shift, and logical right shift (LSR). Okay, and again these are two types: arithmetic left shift and arithmetic right shift. Okay, arithmetic right shift. So what are the symbols? So left shift is this symbol, right shift is this symbol. Okay, arithmetic means here left shift means here 3 less than, right shift means 3 greater than, 3 greater than. Okay, so we'll see one example. First we'll see with the logical shift. Okay, logical shift, logical shift. So logical shift, let us take y equal to so y equal to mm, uh, suppose 0 1 0 if you consider. Okay, so y left shift by one position means, so 0 1 0, this will be gone, so this will come to MSB bit and 0 will become, and whatever the vacant position is there, that will be loaded with 0. Okay, same thing if I do right shift. Logical right shift by one position means, so your value is 0 1 0, this will be, this will go, and this will come to LSB, and this 0 will come to second position, and whatever the vacant position is there, that will be loaded with 0. Okay, so that is nothing but left shift and right shift. Okay, same shift operations you already did, no? And next, one second, I will add the slides. Yeah, that is left shift and right shift. Left shift, and next we will see the arithmetic shift. Arithmetic shift means, arithmetic shift. So arithmetic shift, left shift is same as the logical shift only. Suppose if you consider like uh, so uh, so here if you take y equal to let us take 0 0 1. Okay, I am doing arithmetic shift by two positions. So what you will get, first shift 0 0 1 means, so this will go and this will come here, and this will be shifted here, and whatever the vacant position is there, that will be loaded with 0. Again this is first shift. Okay, and second shift, so this will go and this will come come to MSB position, and this will come here, and whatever the vacant position is there, that will be loaded with 0. Okay, so that means we can say like note, you can remember like this: normal shift operation and unsigned shift operation is same. Okay, so that means uh, so if you take the unsigned shift operation, so left shift is same as logical shift only. Okay, so you can say that normal shift operation, shift operation and unsigned shift operation. unsigned shift operation. Shift operation. Both are same only. Okay. Shift operation on unsigned numbers are same only. Unsigned numbers numbers are same only. Where you will get the difference? So the arithmetic shift, if you take the signed number, let us take m equal to 1 1 0 1. Okay, this is a signed number. Okay, so suppose if you take 0 1 1 0 means this is if it is a unsigned number means normal shift operation only it will do. So this one decide the given number is positive or negative, no. So this is a one means this given number is negative. If MSB decide the given number is positive or negative. MSB equal to 0 means given number is positive. MSB is 1 means given number is negative. Okay, that is signed and unsigned numbers. Suppose this one M equal to you are doing right shift by one position. Okay, here what happens means M equal to, let us take this is my original value. This will be holded. That means whatever the signed bit is there, that will be holded, and after that this will be shifted. This will be shifted. Okay, so this will come here, and this 0 will come here. Like this, it will do the arithmetic shift. Okay, so mm, that is the same. That is the case, and one more special case is there. Suppose you take, let us take reg signed. Okay, reg signed 2 down to 0, a comma b. Okay, let us take the signed numbers. Okay, so normally this net data type and reg data type, variable data types are unsigned data types. If you want to represent in signed, you need to represent like this. That means reg signed, or otherwise you need to use integer. Okay, so again reg signed, reg signed 2 down to 0 c. So this is how many bits? 3 bits. Okay, within an initial begin and block, what I am doing is I am keeping a equal to -2 and b equal to -3. Okay, uh, so uh, so here uh, like this you need to initialize. Okay, suppose there is a special case is there. Special case. What is this special case means? Suppose a equal to 3 tick binary 0 1 0 0 1 x 0 1 x. Okay, so 0 1 x, if I want to find not of logical not of a, what value you will get? So that is 0 1 0 means this it will take as 1 only. 0 1 1 means it will take as 1 only. Okay, so that means not of 1 means you are getting 0 only. Okay, suppose if you take one more value a equal to 3 tick binary 0 0 x. Okay, 0 0 x means what? First if you take x value as don't care value as 0, you are getting 0 0 0. The total value is 0. If you take x value as 1, you are getting 0 0 1. You are getting what? 1. Okay, so in this case you are getting a equal to what? X. A equal to x. Okay, so this is the special thing. Okay, special case for this logical not operation. And next is relational operator. Relational operator. So relational operator, if you see, so here the output for the relational operator, the output can be false condition 0, output or true condition, or it can be unknown condition. False condition, true condition, or unknown condition. Suppose if you take a equal to 4 and b equal to 3. Okay, let us take case 1. Case 1. Okay, so if a is greater than b, okay, what is the output you are getting? This is true only. No, 4 is greater than 3, so output equal to 1. Okay, if a is less than b, So what is the output you are getting? So is 4 is not less than 3, no? It's a greater than 3. You are getting output equal to 0. Okay. If A is greater than or equal to B, okay. So greater than or equal to B means output it's a greater only, no? So output you are getting 1. Okay. If A is less than or equal to B, so this condition, both conditions not satisfying, the output equal to 0. Okay. If condition is satisfying, then you are getting the output as 1. If condition is not satisfying, the output, you are getting the output as 0. Okay. And case 3, case 2, case 2, let us take A equal to 3 tick binary 0 0 x, and B equal to 3 tick binary 1 x 0. Okay. Suppose if I want to consider A greater than B. Okay. So what are A values? 0 0 0 and 0 0 1. Okay. And so this is 0 and this is 1. B equal to 1 0 0 1 0 1 1 0 1 1 0. Okay. So this is 4 comma 5, 4 comma 5. Okay. So that means in the relational operator, if anything is don't care, actually the output you will get what? X only. Output you are getting x only. Okay. So that is the relational operator. And next is equality operator. Equality operator. So equality operator means, here if you see the equality operator, there are two equality operators are there. One is logical equality, logical equality, and next one is case equality, logical equality and case equality. So logical equality is so again there are two types: equal, not equal; logical equal, logical not equal; and next case equal, case equal, case not equal. Okay. Suppose so the symbol is here, logical equal is this is the symbol, and not equal means this is the symbol. If you consider case equal, three equals are there, this is the symbol. Okay. Not equal means not two equals are there. Okay. Suppose we will take one example. Suppose if you take one example, A equal to 3 tick binary xx1 and B equal to 3 tick binary 0 1 1. Okay. I want to check A logical not equal to B. Okay. So A logical not equal to B means here so yeah, in the logical not equal, uh, so so this you need to remember. In logical equality operator, uh, output output equal to x, that is don't care if any one of the bit is don't care. If any one of the bit is don't care, bit is don't care. So here this any one of the bit is don't care means logical not equal to B is what? You are getting the output is equal to x only. Okay. In the tool also you can check. Okay. Just to give the values, these values. Okay. And check for the condition. Okay. And so here next case equality, if you see, so let us take case equality. A equal to 3 tick binary 101 and B equal to 3 tick binary 3 tick binary x01. Okay. So A case not equal to B. Okay. Case not equal to B. Two equals are there. So here in case equality what happens? It will compare with the don't care also. Okay. In case equality compare with unknowns also. Okay. So I will write here in case equality. In case equality, it will compare. It will compare with unknowns also. With unknowns also. Okay. Suppose here let us take a equal to, a equal to, so here what is the output? So 101, this is a, and b equal to, b equal to, so here 001 and 101. Okay, so one thing, it is not equal. Okay, not equal is satisfying. Output equal to what? 1. Output equal to 1. Okay, like this. Here if you take one more example, a equal to 3 tick binary 1x1 and b equal to 3 tick binary 1x1. Okay, so a not equal to b, not case not equal to b. So here what it is checking? So that means both are equal, no? So it will compare with x, 1 with 1, 1 with 1, both are matching. So output will be what? The condition is not satisfying, that output is equal to 0. If condition is satisfying, the output is 1, and the condition is not satisfying, the output is 0. Okay, and last is conditional operator. Conditional operator. So conditional operator, so or we can call as ternary operator. Ternary operator. So what is the ternary operator? You have three operands in the conditional operator. You have three operands. Okay, so the syntax will be like this. Syntax will be condition, condition, and next expression. Okay, true expression or false expression. So that means if condition is satisfied, then the true expression is assigned to expression. Okay, if condition is not satisfied, false expression is assigned. Okay, suppose we'll take with this mux also, mux only. Suppose for the mux 2 cross 1 mux, I can write with ternary operator. Okay, conditional operator. Suppose if you take a and b, this is 2 cross 1 mux. 2 cross 1 marks and selection line. Okay, and this is output y. Okay, with conditional operator I can write y equal to s question mark. Okay, b, or otherwise a. So that means if y equal to 1, okay, sorry, if s equal to 1, if s equal to 1, y is assigned to b. Depending on the selection line, it is connected, no? Or otherwise, if s equal to 0, y is assigned to a, like this. Okay, like this it will execute. Okay, so these are the operators we discussed. Okay, so first we discussed about so in glance, what are the operators we have? Operators in Verilog. First logical operator. Logical operator. So in logical operator, you have AND operator, OR operator, and NOT operator. Next, you have bitwise operator. Bitwise operator. In bitwise operator, you have AND operator, OR operator, and XOR operator. XNOR. XNOR, two symbols are there. Not of XOR, or you can use this symbol also. XOR of not. Okay, XNOR. XNOR, and this is not operator. Not operator. Okay, and next you have reduction operator, unary operator, reduction operator. So in reduction operator, you have like NAND of A, okay, NAND of A, and NOR of A, like that. Okay, NOR of A. This is like that. Okay, and next is concatenation operator. Concatenation operator. So concatenation is nothing but combining. So you are using this one, and repetition by using concatenation. Repetition by using concatenation. Repetition by using concatenation operator. The syntax will be like this: n of x, n of x. Okay, and next you have one second. Next you have we have shift operator. Shift operator. Shift operator. So shift operator, we have two types: logical shift and arithmetic shift. Arithmetic shift. Okay. Again, right, left, right shift, left shift. So right shift will be this symbol, left shift will be this symbol. Arithmetic shift also right shift, left shift. So right shift will be so like this. Left shift will be like this, less than. Okay, and relational operator. Relational operator. The symbol is greater than, less than, greater than or equal to, less than or equal to. Okay, and next you have equality operator. Equality operator. Equality operator again two types: logical equality, logical equality, and case equality. Equality. Again in this equal, not equal. Equal means this is the symbol. Not equal means this is the symbol. And here also equal, not equal. Equal means 3 equal to here. For the case equal, not equal means not of 2 equals. Okay, and conditional operator. Conditional operator. Conditional operator, or we can call as ternary operator. Ternary operator. Okay, ternary operator. So expression, syntax is expression, expression, true expression, condition, expression, true expression, or false expression. Okay, and next you have arithmetic operators also. Arithmetic. Arithmetic means just addition, addition operators, plus subtraction. Subtraction means minus, subtraction, minus, and division. Division. Okay, forward slash, modulus. Modulus means like this. It will give the remainder. Two stars also there. This will give. This will give. This will give the power. Power. Okay. These all are the operators. So this is about the operators. Hope you understand. Any doubts or queries in this session?
No, we'll go through it.